Hello everyone, I'm Sean Rosier, an assistant professor in the landscape architecture program, part of the School of Design. And what I'm here to kind of show you guys how to do today is make a 3D model or 3D mesh of a given piece of topography, just like this one here. And this is the, I guess just for reference, this is the Hokie Stone Quarry in Blacksburg, where all the material that covers all the buildings on the various Virginia Tech campuses, all that rock gets taken out of here. I've just got this on hand because I'm using it for my second year design studio. My students have found this really useful because they obviously can't get into this quarry as part of their fieldwork. So there's all different kinds of uses for these 3D models for architects, landscape architects, interior architects, and industrial designers. So this is kind of the end product, but the getting there is perhaps not so straightforward. So if we just scoot over here and zoom in a little bit, this is the contour data, which most of you are going to be fairly familiar with. That's an abstraction of topography elevations. Each of these lines here, these contour lines, represent a 2-foot change in height from each other. So by and large, most times you get contour data, it's going to come in 3D like this. Each line is kind of elevated 2 foot up from its neighbour, or down, depending on what direction the slope's going. But doesn't always come in with that. If it does come in flat, it still has its elevation attribute within the line. You just might need to use ArcGIS to basically array it to put it into 3D space as opposed to 2D. But it's a very simple command using the set feature by 3D attribute, I believe, and it basically just spits that out like that. So this contour data originally downloaded from the town of Blacksburg GIS servers as a shapefile and took it into ArcGIS, and then exported that as a DWG here and trimmed it down to kind of the rough proximity of our site in here, and then brought it into Rhino. So to go from this kind of line work data to the 3D mesh, which is what we really want, we have to use a kind of extension or a plugin to Rhino, which in version 6 and 7 is built in. If for whatever reason you're using Rhino 5, you need to download Grasshopper and install it. But Grasshopper is really fantastic. It's a nice kind of parametric modelling interface, which is used by a lot of architects, landscape architects, and probably interior architects as well. I'm also assuming industrial designers probably play with that because they spend a lot of time in Rhino. So to start off with, what we want to do is bring in a curve command, and what these little commands or modules in here do is basically some of them will tie geometry in that Rhino modeling space and bring it into this Grasshopper kind of parametric canvas, and other ones will manipulate that within the canvas, right? It doesn't manipulate out there and here. So while Rhino is like a virtual modeling space, Grasshopper is kind of a little bit like a virtual space within a virtual space. So kind of once you get your head around that, it kind of becomes a little bit clearer, but I know it's a little bit odd to think of straight away. So right now, Grasshopper doesn't have any interaction with these lines in here, right? So the first thing we're going to do with our curve module is basically link those curves and bring them into the Grasshopper space. So we're just going to select all of our curves and hit enter, and that links them in. So when you click on a module and it changes to green over here in the model space, basically what that's saying is I'm selecting this module which is linked to this line work in here. The next thing we want to do is bring in a divide length command. So if we hover our mouse over that, we can see it divides a curve into segments with a preset length. So we bring it to the right hand side there, and by and large Grasshopper works left to right. So you have these little nobbins, these little handles. What we do is we drag that into there, and if you hover over each of these, it should give you a little description of what each one's looking for. So this one's asking for a curve on there, so we drag our curves into here. and this one here is asking for length, I believe. Yep. So basically what this module is asking us to do is you have all these curves over here, and you want, and using this module here we can divide them into basically chunks. Each one has a chunk. So this is where you need to have a little bit of, I guess, nuance, not necessarily nuance, but a little bit of understanding of the scale of things you're working at. So obviously if we are using a very large scale data set, say the whole of Montgomery County, we wouldn't be able to divide up those lines with as much a smaller number as compared to if we were using a data set like this, or even smaller like an individual building lot. So having an awareness of that, but also having an awareness of the contour interval as well. So 2 foot here is pretty close intervals. 1 foot or half foot, if you have that data available, will mean you can't divide that length as closely as well. But if you're using 5 or 10 foot contours, then you can use a much closer division. So for speed's sake, what we'll do here is just to quickly show you how it works, is we're just going to put in 6. My Rhino model down here is in feet, which you can always check your units in here. So we are going to divide each one of these curves into 6 feet chunks. And if we plug that in there and give that module a little chance to do its thing, and if we zoom in, we can see that between each of these points in here, that's 6 feet. Looks a little bit crazy, but we'll get there. The next thing we need to do is use the flatten tree command, and what this basically does is it just kind of orders and puts everything kind of into neat little lines in here. And this is one thing to just be aware of, and specifically for this this script here, or set of modules. P does not go to P, and T does not go to T. Clearly enough, P in fact goes to T. And what that does is that basically just orders all the data up until this point. And this is a very quick little chain of commands. All we need to do here is convert all those bunch of points into a mesh. And we want a Delanoy mesh in particular. So we type in DEL and we see Delanoy mesh. And funnily enough, T goes into P. And that's depending on the scale of your data and how closely you've divided it. That may take 30 seconds to a minute, if not longer. This one was pretty quick. So if we were to grab all these guys up until here, right click in the middle of nowhere and go preview off. It's basically what, by default, it displays each and every stage all at once. So by grabbing these ones and turning them off, we only leave this one still displayed. So if we go back into our Rhino space here, we can actually see that it's made that mesh in a virtual space, if that makes sense. But we can't edit that yet. We can't really do anything with it. It's kind of not even real within the Rhino modeling space. So to make that real, what we do is we bring that into here, we make a geometry component, and we drag mesh into geo. And what you want to do over here on your layers menu over here is make a new layer and call it mesh. I've already got one, so let's call it mesh 01. And basically grab everything, turn preview off, and right click your geo component and bake it. Baking is the command by which you make it kind of real within the Rhino space. It makes it like a physical object. Oop, turn the wrong layer off. If I didn't turn my contours off, there we are. We have a mesh. It's a little bit soft, like if we were to compare it to, if we were to drag this guy across and just compare them. See, it's like a little bit softer, and it's like kind of lacking a little bit of detail. And the reason why that is this one on the right hand side, the original, was created with a much closer set of intervals for the divide length. So let's see what happens if we were to change that to 2. And the beautiful thing about Grasshopper is that you can go back and edit any of these things, and it will kind of transfer all the way through. You don't have to relink things or make a new version of this. Problem with that is if you change something and you've made it kind of way too processor intensive, you have to basically let it play out and wait for it to finish. But we can double click on this guy and go 2, and this will kind of hang or kind of kind of freeze for a second, because basically it's just recomputing everything all the way to that geo component, and we'll know it's ready once that, there we go, flips into being. And so if we re-bake that to our mesh 01 layer and we turn that preview off, we can see it's got much more of that detail back in there. It's not a huge difference, but it does make a fairly decent difference once you start getting down to like this kind of scale in here. Now you can't really edit meshes all that cleanly, so another thing you can do is drop a surface on top of that. So if we jump in here and we use drape, so basically draping a surface atop this. And it kind of has this graphic infinite kind of drop down there. That's if you do it kind of overhanging. You can always drape within the model. It might be a little bit funny because I've got this kind of offcut. Yes, it's going to be a little bit funny there. And within kind of the commands up in here, when you open up a drape command here, we see we have these options. If you click on the spacing one, it's asking us for tell us the point density here. So 1 is high density, I believe. Could be mistaken, but we're about to find out. So let's just drop that across there. Yeah, 1 looked like it was much higher density. So we have our surface here, and let's just put it on a new layer, call it surface. Change object layer, and turn that off, and let's see what that looks like there. Inherently, a surface is always going to be a bit softer than a mesh, because meshes have kind of more kind of angular geometry to them, so it allows for just a slightly higher resolution, but you can't really edit meshes all that successfully. But with the surface, this guy in here, like if we were to hit F10 and grab some of these points, let's just go into plan and grab a couple of these points in here. That's kind of maybe best to do it in here. Otherwise I'm going to cause all kinds of chaos. Let me just grab a couple of these guys here. And we can let's just say we want to make a couple of mounds or something like that. We pull these guys up. And we hit F11 to turn those control points off. So you can kind of just play around with topography in that way. It's kind of good if you want to edit things, just kind of play around with things, but if you're using it as like a base for 3D visualization, you want to get some quick clay renders down, then a mesh is probably slightly better to do that as well. So once you've kind of got this set up, you can do all kinds of different iterations, different alterations of both the mesh and the surface, but as a starting point, this is really useful, particularly when you can't get onto your site physically as well. So hopefully this was useful, and feel free to reach out if you have any other questions.